What if I told you that every number has a kind of secret architecture? A hidden code that once you learn how to see it, it kind of changes how you look at numbers forever. Well, in this explainer, we're going to crack that code together.
Think about it like this. What if every single whole number out there had its own unique, secret fingerprint? A kind of numerical DNA that belongs to it and it alone.
And what if I told you that you could learn to read that fingerprint, like right now in the next few minutes? Well, that's exactly what we're about to do.
All right, first things first. Let's meet the main characters in the story, the prime numbers. These guys are the absolute fundamental building blocks for all other numbers.
So when you boil it all down, we're really just dealing with two types of numbers. On one hand, you've got prime numbers. You can think of these as the indivisible atoms of the number world. They only have two factors, 1 and themselves. Like 2, 3, 17. Then you have the composite numbers. These are more like molecules. They're built from those smaller prime atoms. They have more than two factors, like the number 4, which is just 2 times 2, or 18, which is 2 times 3 times 3.
And here's a fun little fact for you. The number 2 is the only even prime number. I mean, think about it for a second. Every other even number can be divided by 2, right? Which automatically means it's a composite number. It makes 2 a pretty unique character in the whole number family.
And just to add a little more richness to this, there are also these related pairs. You've got twin primes, which are pretty cool. They're just prime numbers that are 2 apart, like 5 and 7. And then there are coprimes. Now this is a really key distinction. Coprimes are any pair of numbers whose highest common factor is 1. They don't actually both have to be prime. For instance, 3 and 4 are coprimes because the only number that divides into both of them is 1, even though 4 itself isn't a prime number.
Okay, so we've met the cast of characters. Now for the fun part. Let's learn the actual method. This is how we're going to crack the code.
The technique itself is called prime factorization, and it's really just what it sounds like. It's a method for finding the prime factors of any number. The whole point is to break a number down until it's written as a product of its prime atoms.
And believe it or not, the process is incredibly simple. We're going to use a technique called the ladder method, and it's just 4 easy steps. 1, you divide the number by the smallest prime you can. 2, you write the answer right below it. 3, you just keep doing that over and over until you get down to 1. And 4, all those prime numbers you use to divide, that's it. That's the secret code.
Okay, theory is great, but let's see this thing in action. Let's decode the number 120. So, our target number is 120.
It looks pretty normal, right?
But it's got a secret code hidden inside, and we're about to find it.
Okay, let's build this ladder for 120. We always start with the smallest prime that can divide it, and for an even number, that's always going to be 2.
And 120 divided by 2 leaves us with 60. Now we just repeat the process. 60 is even, so we can use 2 again.
Which brings us down to 30. And hey, 30 is still even, so let's hit it with another 2.
And now we're at 15.
Okay, so 15 isn't divisible by 2 anymore.
So we move up to the next smallest prime, which is 3. And yep, 15 divided by 3 works perfectly, leaving us with 5.
And finally, 5 is a prime number itself, so we can only divide it by 5. And that leaves us with 1. That's our signal. We've reached the end. The process is done. And there it is. You see those numbers on the left side of our ladder? That's the code. The prime factorization of 120 is 2 times 2 times 2 times 3 times 5. That's its unique numerical fingerprint. No other number in the universe has that exact combination. So, that was pretty cool, right? We cracked the code. But why does this actually matter? What's the real takeaway here? Well, this is so much more than just a math trick. This idea is so important, it's actually called the fundamental theorem of arithmetic. But here's the really mind-blowing part. This is the bedrock of modern cryptography. The security of your credit card info online, your private messages, it all relies on a simple fact. It's super easy to multiply 2 giant prime numbers together, but it's almost impossible for even the fastest computers to take that huge result and figure out what the original 2 primes were.
All right, you've seen how it's done. Now it's your turn to be the code breaker.
So what's the prime factorization of 36? Go ahead and use that ladder method we just walked through. I'll give you a second to pause and figure it out. All right, you ready? Let's check. You take 36
Divide by 2, you get 18. Divide by 2 again, you get 9. Can't use 2 anymore, so we try 3, which gives us 3. And one last time. 3 divided by 3 gets you to 1. So the code for 36 is 2 times 2 times 3 times 3. If you got that, nice work.
So remember, every single number has its own secret story, and it's told in primes. And the cool part is, now you know the language. The only question left is, what are you going to decode next?